I'm going to talk, well, Astrophotography 101.
Hello, thank you very much. Thank you. Hopefully you can see my screen okay. So, as mentioned, my name's Lee, and I'm an astrophotographer from Bristol. And over the next 20 minutes or so, I'm going to be talking you through how to take your very first astrophoto. And then I'll outline what happens next if you get bitten by the astrophotography bug, if you want to take the hobby a bit further, what kind of equipment you need, what kind of photos you might be able to take. As with the other talks today, if you have any questions, please just pop them in the Q&A box at the bottom of your screens, and I'll be happy to answer those at the end. So I think it makes sense really to start at the very beginning. What is astrophotography? It's really a fancy way of saying taking photos of the night sky, but it's a little bit more complex than that. It's not just pointing a camera up at the stars and clicking the shutter button. You might have actually tried this before. Maybe you've seen the moon or some bright stars out, and you got out your camera phone and you tried taking a picture, and I'm willing to bet the result was perhaps underwhelming, to put it kindly. That's because the things in the night sky, like the stars, are actually very small and very faint, and it's hard for our camera sensors to record them. In fact, for the longest time, the only people that could take astrophotos were professional astronomers with big telescopes and very expensive cameras. But things change, and in our modern times, I suppose I've been doing astrophotography for the last 10 years or so, and even in that time, it's become a lot easier for beginners to take photos of the night sky. There have been huge advances in the technology that we have available and the computer techniques that we can use. So it's possible now to take photos of star constellations just using a camera and a tripod. And that's what I'm going to be talking us through, using that level of kit to produce a photo a little bit like this. Any seasoned stargazers among us may recognize a constellation there. We've got Cassiopeia, the Queen, looks like a W shape on its side there. And if you've got keen eyes as well, you might make out a fuzzy blob over on the right, which is actually the Andromeda galaxy. So how do we take a photo like this? We need two pieces of equipment that I've already mentioned. We need a camera with manual settings, and we need a sturdy tripod. So when I say camera with manual settings, I mean something like a digital SLR camera, one that's got all the dials and buttons on it. Auto mode doesn't work so well with astrophotography. It's a bit beyond what cameras can work out for themselves. Having said that, some modern cameras and even camera phones have things like night sky modes. They can be all right, but you'll get better results. And importantly, you will learn a lot more if you do it this way. So as well as the camera, you're going to need a tripod that you can attach the camera to. That will keep it nice and steady. You might have this kit already, but if not, odds are you'll know someone that doesn't mind lending it to you. Maybe you could buddy up with them to take your first astrophoto together. Try to avoid spending any money if you can at all possible, certainly at this beginner stage. Next comes the most complicated bit, which is turning your camera onto full manual mode and learning how to change 5 key settings. Every camera is different, so I can't tell you exactly how to do this. My top tip is to learn how to change these settings during the daytime, when there's plenty of light, you're nice and warm at home, there's no time pressure, and you can have the camera as manual to hand, or you can look up some YouTube tutorials, whatever works for you. Don't wait until you're under the night sky to learn how to use your camera, because you'll just get frustrated and it'll be no fun. And you'll curse ever watching this presentation and getting started on this route. So we're going to go through those 5 key settings that you need to know how to change. Don't worry about scribbling down notes. I'm very kind, and I've written a PDF handout help guide that you'll be able to download. You'll be given instructions on how to do that at the end of the Stargazing for Beginners session that we've got for you today. So the first setting that you need to know how to change is your lens aperture. This controls how much light your lens lets in. You just set it to the lowest number that you can. And what this number is will depend on the lens you have. It will probably be something like f2.8, f3.5, f5.6. Don't worry if that sounds confusing. You don't need to be a professional photographer. You just set it to the lowest number that you can, and then you're done. Easy peasy. Next is your lens focal length. You normally change this by twisting the barrel on the lens. Focal length controls how zoomed in you are. So you start by setting this to the lowest number that your lens will allow. It might be 24 millimeters, 35 millimeters, 50 millimeters, something like that. Just as with the lens aperture, you go with the lowest, and this will make things easier for you. You can always play about with different settings later. Note that some lenses have a fixed focal length, which you can't change. If that's the case, it's absolutely fine. Don't worry about it. Just go with whatever your lens will allow. Most lenses work that way. And then we have focus. You normally change this on the lens. Stars are really far away, so we set our lens to focus on infinity. This might sound like a complex thing to do. It's not really that hard. You just twist the barrel of your lens until you see a little marker line up with the infinity symbol. Most lenses work that way, so you should be all right to do that. And then we have camera ISO. This is a setting that you'll change on your camera rather than the lens. There might be a dedicated button for it. I know my camera has an ISO button. Some cameras you need to dive into the menus to be able to change ISO. So ISO is essentially a measure of how sensitive your camera sensor is to light. Try 800 as a starting point. You can always change it later if you need to. Still with me? Good. Next is one final setting, which is the camera shutter speed. This controls how long your camera will collect light for. If you're doing normal daytime photography, this is normally a fraction of a second. So if you're taking photos outside, taking some landscapes, doing some beach photography, whatever, you might be shooting at 1/200th of a second, really fast, really, really fast. But we are doing astrophotography now, and stars are faint. So we're going to set our shutter speed to 15 seconds, just as a starting point. It's very, very low. That's why we need to have our tripods that keeps our cameras nice and steady, because you can't physically hold a camera completely rock steady for the amount of time that we need to for astrophotography. So those are the 5 key settings. Well done. If you are still with me, that's the complex bit done. And remember, I've written that PDF guide that you'll be able to download at the end. That will help you with all of that. So let's imagine you have taken my advice and you've learned how to change those settings during the daytime. So there's no pressure. You're pretty clued up. You can do all of that. That's all good. Next, you just need to wait for some clear skies. Then you head out, you point your camera up with the suggested settings, and you click. You check the screen on the back of your camera, and you might get a photo a bit like this. I know it's a little bit underwhelming, but that's just because it's our first shot. I took this from my back garden in Bristol about a month ago. The light pollution is terrible, so that makes it even harder. But what we do is we tweak those different settings, those 5 settings, and we essentially use trial and error to make the picture better. So we'll go through the whole process as an example. I think that this picture is a little bit dark. So let's take the shutter speed from, we started at 15 seconds. Let's take it to 30 seconds. Let's let a lot more light in. And then, whoa, okay, well, it's certainly brighter, but I think it's too bright. So let's take it down a notch. Let's try a shutter speed of 25 seconds. Okay, that's more like it. I don't think that's too bright or too dark. But if you've got keen eyes, you might have noticed those stars don't look quite right. So a top tip for you is to not just glance at the photo on the back of your camera screen after you take it, but actually zoom in. Take a closer look, and we can see those stars are not in focus. Those are a little bit blurry. I thought I'd set my lens to infinity, but I must have got it slightly off, or sometimes the camera lens itself is slightly off. So you might need to just tweak it one side or another. So let's do that. Tweak the lens focus, try again. Okay, progress, one step forward each time. Now those stars are sharp, but can you see they're little lines rather than pinpricks of light? That's a sign that our shutter speed is too long. The Earth is actually rotating in space, and if our shutter speed is too long, then we pick up that movement in the stars, which is actually kind of mind-blowing if you think about it. But most of the time in astrophotography, we don't want our stars to be lines, we want them to be little pinpricks of light. So let's knock a few seconds off that shutter speed, and hey presto, this is better. We have nice, round, sharp stars. And look at this. We have taken an astrophoto of Ursa Major, the Great Bear. Congratulations. It's fair to say that you might not win any awards for a picture like this, but the photo isn't too dark, it isn't too bright, and the stars are sharp. That means it's a good first astrophoto. And what you can see in your screens right now is a realistic expectation of what you could achieve on your first outing taking photos under the stars. And the skills you'll learn and the skills that you'll use are the foundations upon which you can build to get better and better and better each time. I've given you some suggested camera settings, but that's just what they are, suggestions. If you follow the same process as I've described, using trial and error to change the settings, you'll end up with the best picture that you can take. The reason I can't give you definite best settings to use is because our cameras are all different and our skies are different. So I mentioned that I took this photo from my back garden in the centre of Bristol about a month ago. I've got really bad light pollution. That makes my sky quite bright. Maybe you live in the countryside and have nice dark skies. You'd get a different result there, such as this photo of the same constellation. I took this a couple of weeks ago. I was actually photographing a wedding at a manor house in the countryside outside of Bristol. It's just past the airport. The skies there were much darker. So after the first dance of the bride and groom, I snuck out to take some pictures of the stars. It was the same process as I've described. I just use a camera and a tripod and then trial and error to hone those settings down. But maybe you can see that getting away from light pollution really helps with this kind of astrophotography. Now, the first time that you try taking an astrophoto, it might take you an hour or so to get a good result. Make sure you wrap up warm. That's some of Andy's excellent advice from the first talk. Gloves and a hat, definitely. And just take your time. Don't rush it. Don't be impatient. You need to be patient with astronomy and astrophotography. Just have fun with it. With a bit of practice, you'll be able to dial in the settings and get good pictures within just a few minutes. When you get to that stage, you might learn a bit of photo editing. That can make your pictures really pop. You can even make star trail pictures by taking lots of photos one after another, and you can combine them in some free software. I'll give you some links about that in the PDF that I've mentioned that you can get at the end. So that's actually the first part of my talk that's complete. That's how to take your first astrophoto. It's a good skill. You can have a lot of fun with it. And it might be that you are forever happy taking photos of constellations, devising interesting compositions and improving your art. Perhaps finding some really nice foreground interests. So you can have interesting compositions with foregrounds and background stars. But I have to warn you, fair warning, there is a chance that you will get bitten by the astrophotography bug. What can you expect if you get pulled deeper into this rabbit hole? Well, everyone's journey is different, but broadly speaking, I think that there are 4 stages that you might go through. And I would describe the first stage as beginner. And it's exactly what we've been talking about so far. It's using a camera and a tripod to take photos of the constellations. You're probably using kit that you've got already or you've borrowed. Beginner might be a bit misleading because you could spend a lifetime perfecting this form of astrophotography. You could end up taking professional level pictures. But in general, if you find that you're really enjoying taking astrophotos, after maybe everyone's different, but maybe 6 months to a year, you might want to try something different. You'll likely go through this intermediate stage. And the big difference here is that we're swapping out our standard camera tripod for what's called a tracking mount. This is the kind of thing Ryan had mentioned in his talk about telescopes. This tracking mount is some specialist gear designed for astrophotography. If you wanted a tracking mount for a camera and a camera lens, we're talking maybe 300 to 500 pounds, that kind of region. Now, what a tracking mount does is allow you to allow your camera to move and actually track the stars as they appear to rotate above us. That means you can take much longer exposures without getting any of those streaky stars that we saw earlier. You might also like to buy a telephoto lens. This can cost anything from a few £100 upwards. And with that level of kit, your choice of targets in the night sky becomes much larger. You could take photos like this of the Andromeda galaxy. You can see a bright core there of many, many stars, and there are some dusty lanes in the spiral arms. Intermediate level photographers also start to get more into image processing. That's editing your photos in software like Photoshop to bring out as much detail as possible. You could easily spend a few years at this stage. And then maybe you want to take things further. You could become an advanced astrophotographer. You'd leave your camera lenses behind and instead buy a telescope. These can be heavy, so you need a bigger mount to both track the stars and keep the telescope nice and steady. You could still use your digital SLR camera, or maybe you buy a specialist astro camera. Whatever route you go with, you're probably spending about £2,000–3,000, something in that kind of range. If you live in a light polluted town or a city, then with advanced level equipment, I've actually got some good news for you. You might realize that your bright skies aren't as much of a disadvantage as they have been up until this point. Specialist cameras, filters, and processing techniques that have been developed, many of them in just the last few years, really help to combat light pollution and pierce through the murky skies above us. If you're in the countryside with dark skies, you definitely have an advantage. But even from a city, you can take photos like this. This is the Rosette Nebula. I photographed this from Bristol a few years ago. It's a glowing cloud of hydrogen gas. It's about 5,000 light years from Earth. Isn't that incredible that we can take photos like this using this kind of advanced level equipment, even from a city? Completely blows my mind. To take photos like this, you don't actually take one picture, you take lots, maybe hundreds, and combine them all in a process called stacking, but that is a topic for another talk. So let's say that you've spent, I don't know, maybe 3 to 5 years at this stage, this kind of level of progression, but you want to go even further. This takes us to the final level, which I call obsessed. You have to be a bit obsessed by this point. You'll buy a better quality telescope, or perhaps even one called an astrograph. Ryan mentioned these in his talk. Astrographs are designed specifically with astrophotography in mind. You'll also get gadgets that attach onto it, like a guide scope and an autofocuser. You'll remote control your mount and your camera. Maybe you'll use a laptop or maybe Wi-Fi and an app on your phone that allows you to collect photons of light, even when you're actually not there by the telescope. By this point, you've probably spent more than £5,000 on equipment, perhaps much more, and you've probably got 5 to 10 years of experience behind you. And I think something important happens at this stage as well, which is that you realize that image processing and editing is at least as important as all the hardware, like your telescope and your camera. You might even move away from Photoshop and try more specialist astrophoto processing software. What we're looking at right now is actually a photo of some of the astrophotography kit that I've used, all from my back garden in Bristol. I live really close to Bristol Temple Meads train station. If I'm out setting my kit up, I can hear the ding dong, the next train to arrive at platform 5 announcements. So the light pollution that I have is about as bad as it gets. But I still want to share with you a few photos I've taken recently so that you can see what's possible with this modern equipment. This object has the fantastically snazzy name of IC1396. Astronomers sure know how to name things. It's a gigantic cloud of gas and dust. It's about 2,400 light years away. And many of the stars that we can see are forming within that nebula. The brightest object we can see over toward the right of the picture here is called the Crescent Nebula. This is within the constellation of Cygnus. The Crescent Nebula is about 5,000 light years away, so more than twice the distance of that previous photo. And it was formed when stellar winds collided with gas ejected from a dying star, sent shockwaves out into space, and it's surrounded by huge clouds of hydrogen gas that we can see here in red. Now, this photo is of an object that's very well known to amateur astronomers. The official name is the Pleiades. You may have heard its nickname, which is the Seven Sisters. It's a cluster of hot young stars, 444 light years from Earth. And these stars are passing through a nebula, lighting it up from the inside, making it glow blue. I took this photo November last year. I think it might be my favorite picture that I've taken so far. There's a lot of detail in it. And remember, this is all from the center of a city. Mindful of the time, so I'm going to share just one more picture with you. This is actually my latest one. I took this a couple of weeks ago. This is called the Elephant's Trunk Nebula. It's full of baby stars. Say babies, they're about 100,000 years old. It's babies as far as stars are concerned. So I hope those few astrophotos show what it's possible to achieve nowadays, even if you have loads of light pollution. But whether you want to eventually take photos like this, or you just want to dip your toe into the hobby, it all starts with taking your first astrophoto, as I described earlier. So with that in mind, I'm going to give each and every one of you a challenge. Take an astrophoto. Just use a digital SLR camera and a tripod. What you've learned today and the PDF guide you can get at the end, your photo doesn't need to be spectacular. So long as it's well exposed and the stars are in focus, then that's a win. And then I'd love to see the best shot that you manage. So please email it to me at the address shown there, leepullen@hotmail.com. I really like helping beginners, as you may have gathered, and seeing what you produce makes it all worthwhile.